We will now go over page 159 in example number 3. And so now it's when it gets really fun. Sean estimated the attendance at a college lacrosse game was 3,000. So he was kind of looking out into the crowd and he's like, that looks like, I don't know, like 3,000 people. Or maybe he did it even better. Like maybe he tried to count them or something. I don't know. But the actual attendance was 3,296. So what is the percent error in Sean's estimate? So we're trying to find the percent error. So again, to find the percent error, you need to actually first find the error. So that's actually not given to us. We only have the estimated amount and the actual amount. So we have to find the error, just like in the percent change, we had to find the change. It does say here a little tidbit about percent error describes the accuracy, like how accurate something is measured, or the estimated value compared to the real value. So here's how we're going to do it. We're still going to use part equals percent times the whole, but now the part is the error. It's kind of like our change, the change between what we thought it would be and what it actually is. The percent error is the percent, and then the actual is the 100%. This is key, that we're going to use the whole as the actual. So if we don't put the right number here, it's going to mess us up. So here we go. We're going to find the percent error. Let's try to solve Sean's problem. So to find the error, I'm going to take the estimated value, what he thought it was, and I'm going to subtract, I shouldn't say predicted, the actual value. When I take the estimated value and I subtract the actual value, my answer is the error. So, and this is in your book on page 159. The 3,000 was the estimated, that's Sean's guess, and the 3,296, that's what was actually there. And we subtract, we should be getting a negative, but notice these absolute value bars. And they're doing that because they're just trying to find the amount. They're not concerned whether he was over or under in his error, just that he was off by 296. So now that we have that, we have the difference in attendance, that's the error, that's the 296, equals the percent error times the actual amount, just like we had here earlier. So now we're going to fill the numbers in. 296 equals a number, the percent, times 3,296. So this looks like a decimal here in this graphic, but it's actually multiplication. It's being multiplied. So now we're going to divide again to solve, just like we did before. When we divide, this time our answer is actually going to be a repeating decimal. It's not going to be terminating. Or if it's terminating, it's really long. But I'm pretty sure it's repeating. Anyway, so we're going to kind of round. So we're just estimating. We get some of the numbers, we write them down. Notice how the book writes 4 numbers behind the decimal. Then we're going to move the decimal 2 places to the right so that we get a percent that's about 9%. See, when we move the decimal here, 1, 2, you would get 8 and then 0.98. But if you round to the nearest percent, then this 8 would become a 9. So it's about 9%. Round to the nearest whole percent. So that's our example of percent error.